I'm Muhammad Daniel Sarzel. As for my part in this case study, I will be doing the 10-degree angle. So this is my setup, which I'm using a book as a pen and a box as a support to create 10-degree angle, which you can see here. 10-degree angle, and the distance between the both end of this rubber band is approximately 10 centimeter, as you can see, and I will be launching it on 10 centimeter Mark II. I will be using my other phone to set the time for this motor cap to hit the ground. So let's go. Centimeter mark here. I will be launching it shortly. This is the time taken.
For this experiment, first we have to use this setup. Okay, this setup. So for the distance of the rubber is approximately 15 centimeter. As you can see, it's the end of the tip of this caliper and this caliper, and then the distance of the rubber to be extend is 10 centimeter. 10 centimeter from this line, so it's approximately at this. Let me mark it for you at this point. So for the angle, I use the box down below, and I used to mark the angle at this side. So the angle is 45 degree. So this is 45 degree. Okay, 45 degree. Okay, now we can proceed with the experiment. So the experiment requires us to fly this water bottle cap. Okay, so let's extend. Until it reaches the 10 cm point, and then we release it.
Okay, good evening everyone. My name is Muhammad Haris bin Ismail, BNJ20103. Before we proceed to the calculation of angle 10 degree, 30 degree and 45 degree, we need to find the length of x1 and x2. So the equation given is 0.5k times x2 squared minus x1 squared equal to 0.5 nv squared. Okay, the unstretched length is 12 cm and the stretched length is 15 cm. Okay, for the x1, we need to minus the stretched length and the unstretched length, and we get 3 cm. We convert it to meter and we get 0.03 meter. Okay, to find x2, first we need to use the theorem Pythagoras to find the hypotenuse, which is x2 here. So we get 12.5 for the hypotenuse. and then we plus the 12.5 plus 12.5 and then minus with 12, which is unstretched length. We get 13 cm. We convert it to meter and we get 0.1. Okay, the calculation for 10-degree angle. First, we use the two equation, which is V cos theta equal to Vx. And then we find Vx first to get to the equation 1. Okay, Vx is equal to Sx over T. Sx is 1.48 and time is 0.33, and we get 4.485 meter per second. Okay, and then we substitute the equation 2 into 1, and we get V cos 10 degree equals to 4.485, and then we get the equation, and the value is 4.554 meter second. Okay, then we put the value of V into the equation. Okay, equation 0.5k times x2 squared minus x1 squared equals to 0.5 mv squared. Okay, so we put the value into the equation and we get the k is 2.625 Newton meter. Okay, for the 30 degree angle is the same from the 10 degree angle with the same equation, and we get the Vx is 3.792 millimeter per second, and then we substitute the two equation into one, and we get the V is equal to 4.379 meter per second, and then we put it into the equation and we get the K is 2.375 Newton meter. Okay, for the 45 degree angle, it's the same from the 10 degree and 30 degree. We put the value into the equation 1 and we get, into equation 2, and we get the Vx is equal to 3.652 meter per second, and then we substitute 2 into 1 and we get the V, which is 5.165 meter per second. Okay, then we put it into the equation and we get the K is 3.375 Newton meter. Okay, that's all for me. Thank you.